Welcome. In this installment of programming tutorials with processing, we're going to take the keyboard and extend it a little bit so we can use WASD to fire a projectile from the player. So we'll be looking at adding in simple rectangle-based collision detection. We'll have a projectile, and we'll be adding in some other keys so we can control that. We're just exploring one of a million different methods of how you could implement this. So this is not the holy grail method of doing it. It's just a method of adding in some more keyboard fun so we can actually turn this into something that's a little bit more interesting and playable. So the first thing that I am going to do is go and grab my timer that I've used before because we are going to need to use that. So I'm just copying over the timer from a previous project. So if you followed along during Duck Hunt, you can go grab it from there and then you'll be in good shape. So we now need to make a class for our projectile. And with this, it's going to have a lot of the same kinds of things that we work with. And then we're going to, after we step out this class and get it kind of blocked in, then start adding in our additional keys for detection. The projectile will, of course, have our standard X, Y with height, VX, VX and VY because, well, we need those. And it's going to need a Boolean that keeps track of whether this projectile is active or in its resting state. To build out the constructor, now our projectile isn't going to take any parameters when it's created. We will be having a fire method that will then take in the location it should start moving from and then figure out what is the current direction it needs to go and work with it that way. Oh, I already typed that. X is equal to, we'll just make our projectile 10. And our width, our width is 10, our height is 10, and then our X is just going to, it doesn't really matter because we're not going to be showing them on screen because our projectiles are going to have their Vx, Vy equal to 0, and they will start out with their active state equal to false. So that gives us the constructor. And now we will have 3 more methods for now. I'm sure we can come up with reasons to add more. So void update and display. And then we're going to have a third method, and this will be fire. And fire is going to take some parameters. We need to pass in where it needs to start, and we're going to pass in the value of how big the object is. We need to know the height and width of the object so we can determine where the projectile needs to be when it starts at the center of that object. So we will have a starting X, starting Y, starting width, and starting height. So we pass those values in. So with that, we can probably figure out our update and display methods. And fire is going to be the one that probably takes a little bit more effort to go along with it. So let's worry about fire first because that really is the most interesting one. So when a projectile is issued the command to fire, the first thing it should do is set its active equal to true. And after it sets active equal to true, it needs to figure out where it wants to start from. So we need to set the x and y effectively equal to the, in this case we're setting up these projectiles will be fired by the player, so we're passing in the player's x and y here. So then it will be the starting x, which would be the top left corner, because right now we're working with rectangles. We will be replacing those with sprite images, which again draw from the top left rectangle. So if I want to offset and put this at the middle, so I take the x of the player, I add in half of its width, so SW divided by 2, and then I need to go back half of my width, the player's width, to get it, because right now if we want it to be dead centered. So we'll play with these once we have them drawn on screen so you can actually see when we change around these values how it does impact it. So I arrive at these values by starting out with SX and SY, and it's like, oh, we're always firing from the top left corner, but I want to fire from the middle because that just makes more sense when I'm firing in all directions. So we need the width of the player, or the height of the player, if I can type correctly. And then we need to subtract half of our height as well. So we pass those in. Then we need to set our x and our vx and our vy based on whether WAS and D have been pressed. And we haven't worked that language out yet, so we'll come back to this and finish up fire in a little bit. So now when we move into update, update's going to look similar to what we've used before. X plus equals Vx, Y plus equals Vy. And then we're going to just have our boundary check go on. So if our x is less than 0 minus the width of the projectile, meaning it's now off screen, or x is greater than width, because again we're drawing from our top left corner, that means we've hit our horizontal boundary and got off screen. So I will just say active is now equal to false. So we animate it until it's all the way off screen and do that. Now, I could put all of this on, in one single if, but it's just, I think, a little easier to digest if we separate out or the horizontal and the vertical calculations. So 0 minus h is really just negative h, but I like to think of 0 as the left margin, and then we're also going over the width of, or height of the object. And whoop, wrong key, missed my pipe key there, and then y is now greater than height. So we can now once again active is equal to false, and return and close that out. So now we have our update. Display. So display is going to need to do one thing, and we're going to change how we draw our ellipse, because right now I'm not going to draw rectangle projectiles, I'm going to draw circles. That way I don't have to worry about which way they're pointing, because if we want to rotate them, then we have to add an additional calculation. So right now we're just going to kind of use little round, round bullets or round projectiles. It'll just simplify things. But for now, if we just change it to our ellipse mode, we can choose whether we draw from our corner, or the default is ellipses draw from center and rectangles draw from corner. So we do have these modes that we can change of where they start drawing. So we'll just make our ellipse draw from the corner. And because I already have a red object on screen, I will make my projectiles yellow. And then we just draw it at x, y, width, and height. So a lot of things are, well, pretty much the same. I mean, there's just not a lot of difference here. We just are going to have to figure out under fire how to set our Vx and Vy once we utilize this. Now before I go on, I noticed there's this little gray underline, and it tells me the parameter of sh is not being used. And I was like, That's troubling. And I go y, sy plus, not sy, sh. That makes more sense because we're doing sh and h. So got, when you notice red underlines, even a gray underline, it's trying to help you. So processing isn't always mean to us. Sometimes it is trying to be a helper here. So we've set up our core projectile, so now we can add a projectile and do something with it, but we do have to figure out now how we're going to control that movement, that setting the Vx and Vy based on the direction. And for that, we're going to add to our key presses. So to add to our key presses, we'll jump over to our main code here, and we need to add some new variables. We're also going to add in our timer that we'll be working with. So we aren't, in this case, going to be storing 4 directions, because we're just going to make it when you press the key, it sets a current direction, but the moment you let up on a key or press a different key, it changes that direction. So we're only going to be storing one thing at a time. So for that, I'm going to store that value in our current direction. That is the direction that the player is going to be firing when they press W, A, S, or D. Now I need a timer. This will be my firing timer. Now I'm going to have an array of projectiles. And I need to keep track of what is the next projectile. So when I fire one, then I can fire the next one and fire the next one, and then we will go back to the beginning when we hit the end of that array. Now if you find retyping projectile over and over and over is tedious or error prone with your typing skills, shorten it up to bullet or some other variation of name. So there's no magic thing. I just want to call it bullet because the reality is we may not be firing a bullet. We may be firing a heart or a flower or a pie. Who knows? So I try not to, I want it to be more generic with that. Okay, so let's give these directions. As I'm reading the word direction, let's give these variables values, and our current direction will start out as an empty string. Now we have our firing timer. This is going to be how quickly we can fire. So if you want the player to be able to have rapid fire, you use a low number. If you want to slow it down, you use a high number. So I'll just start out with 50 milliseconds. And then we'll create our projectiles as new projectiles. No, we don't want 0. I want 100 projectiles. There we go. Got to get the right punctuation. And it is unhappy here. Oh, it's not new projectiles, it's new projectile. It's like, why is it being grumpy? Projectiles, plural, is the name of our array, and our array is holding objects of type projectile. Okay, now we use the simple for statement. I is equal to 0, semicolon, I is less than projectile's length, and then I plus plus. That will control our iterator while we populate the projectiles array. Projectile square brackets I is equal to a new projectile. So that's easy enough so far. And now we have next projectile is going to be equal to 0. We'll start it out at 0 and then it iterates up, and it will be able to go up to 99, and once it hits 99 we reset it back to 0. So we'll learn how to do that in a little bit. And then we'll just tell our firing timer to start. Now one thing about this is we will want to move to a state function when we add in states. I'm just putting a little comment to try and help remind myself to do that. Okay, So we've got that set up. We've added in our new variables. Now what we need to do with those variables is we need to add some stuff in on our key pressed and our key released. So I'm just going to get rid of this extra code here. We're not using that anymore. I'm just cleaning house a little bit. So we have our key up and key down, all that fun stuff. So now we'll do a if key code is equal to, and previously having verified how this works, we know that 87 is going to be W here. And then curly brace return, and then current direction is equal to W. And close. All right. So I'm going to just do a little copy pasting. So W, A, S, and D. So you can write your own key code checker, or you can go hop online and look up a key code character map, and it will tell you the key codes for everything. So it's pretty easy to find. So now 65 is going to be A, and 83 is going to be S, and finally 68 is going to be D. So that sets my values for current direction, and now let's add to our released here. Oh, we should probably have a comment here, and key down, and key oh, it's not key down, it's key press, sorry, my bad. So it's nice to have that in there because we're probably going to need that. It's a differentiator, so when we add additional functions in for collision detection or rectangle, we'll want that. Now the easy part here is when we release 87, 65, so when we release WASD, they all go to empty string. So that's how we manage our thing. Now, if you want to just remember which ones each of these are, you can put in comments, WASD, so we keep track of that. All right. Now let's go back into the projectile. Now that we are tracking our keys, we can go into the projectile and do something with that inside our fire method here. So we can just simply say if x is less than 0, oh, sorry, I looked at the wrong line there. If current, yeah, I was looking at my boundary check. So if my current direction is W, well, gotta put that in quotes, W, then what we want to do is set our Vx. So W is up, so our Vx is going to be 0, and our Vy is going to be negative, and I'll just choose the speed of 10. Now we may want to store this value, this 10 value, as a speed value, so then I can just change it in one place to make my projectiles faster or slower, but I'll leave that up to you to add that in. Now we can do else if, actually I'm going to just start doing some copy pasting here. Copy, paste, 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 and get rid of that else at the very end. And then this is W, A, S, and D. So W moves me up, A moves me left. So left is negative 10, but Y will be 0. S is going to be down, so X is 0, Y is positive 10, and D is to the right, so Y is 0 and X is positive 10. So that sets those values for me nicely as part of my fire method. Okay. So we're covering a lot here, but not really. I mean, we made the projectile class. It's not that different except it has a bonus method of fire. we're passing in values so we know where to start, and then based on current direction, we'll know what direction to go. Going back into my main code here, let's go up into our draw method here. And what we want to do is first handle the key code stuff, and then we'll handle displaying our projectile. So if our current direction is not equal to an empty string, meaning it contains W, A, S, or D. We don't really care which. We just care that it does now contain something. And this will be, and I'll just put CD for current direction. So if the current direction is there, then what we do is we're going to take advantage of the firing timer, and we'll say if firing timer is complete, and firing timer now. So it forgot a parenthesis. See how it's bright red again. When we ask a method there, 2 parentheses, so you'll see the 2 closing ones because we have 2 opening ones. So we always got to remember that. So when it gives you red, don't freak out. Try and figure out what's wrong. So what we need to do is we need to tell the next projectile in line. So currently our next projectile will have a value of 0. It's the first one in the array. So we'll say projectiles. Just move the cursor so you can see. And see, I really spelled it wrong. Projectiles, square bracket I, close square bracket, no, not I. Next projectile. Our updating and displaying of projectiles uses I's, and my brain jumped to that. So our next projectile, so we're telling that next projectile to fire. And we're going to pass in the player's X, the player's Y, the player's width, and the player's height. And then we need to make next projectile go up by 1. So we can add 1 to it until we get to the end, and then we'll run into the out of bounds exception errors. So we need to control how we make it go up. So we could say next projectile is equal to next projectile plus 1, and then if next projectile is equal to projectiles.length, next projectile is equal to 0. But there's an easier way to write that in one line of code. So we're going to look at both methods of doing this. So we say, so we increase it, and then we say if next projectile is equal to, meaning we're now at 100, but we don't want to be at 100. We want to go back to 99. So if that's the case, then we say next, or not 99, we want to go back to 0. So once we go from 99 to 100, we need to go back to 0, because remember there's 100 projectiles and their positions in the array are 0 to 99. So we use next projectile when it's at 99. We make it 100, and then we check and say, oh hey, it's 100. And then we'll say, let's set it back to 0. Just like that. So these 4 lines of code can be consolidated into one if we write it a little bit differently. So I'm going to comment that out and just write it a little bit differently. So next projectile is equal to next projectile plus 1. And then what we're going to do is we're going to divide it by the number of projectiles in the array. And what we're doing is we're keeping the remainder, we're keeping of how many are left when we do division. So it's like long division with remainders. And then it creates a repeating loop. In this case, it'll be 0 through 99, 0 through 99, and it just keeps doing that. And the method that we're using to do that is called the modulus math operation. So the percent sign in this context is called the modulo, and that gives us it says divide these two numbers, but we don't care how many times it goes into it. We just want to keep the remainder. So next projectile, we just keep kind of adding, but we're only storing the remainder as we do this. So it creates a repeating loop. So if we go with a smaller number, let's say 3. So if our array was 3 characters long, or 3 projectiles long, it starts out at 0. And 0 divided by 3 would be 0, remainder of 0. And now we add in 1. 1 divided by 3. 3 goes into it 0 times, remainder of 1. And then we make it 2. 2 divided by 3 gives us 0 times, but a remainder of 2. Now we add 1 more onto it, and we make it 3. 3 divided by 3 is 1. We don't care that it's 1, but we have a remainder of 0. And then we can repeat. 4 divided by 3 would be 1 with remainder of 1. So we're always keeping that remainder, and as we do that, we get a repeating loop. And with the 3 one, it's 0, 1, 2, 0, 1, 2, 0, 1, 2 is our repeating loop. But in this case, we're going up to 99, and well, I don't feel like trying to speak that out loud. So this is the one-line way of doing it. If that hurts your brain, go look up Khan Academy on math has a great breakdown of how that works. Otherwise, you can use these 4 lines that I've commented out. Where we increase it, we check has it hit our top level? If so, we set it back to our beginning value. So now we've done that. The one thing we need to do is tell the firing timer to start over again. So we tell firing timer to start. So now it repeats. Perfect. All right, so that is now keeping track of firing, and now we need to display our projectile. So we'll use a for loop again, same one we used in our initial setup. So for int I is equal to 0, I is less than projectiles.length, and I plus plus. Curly brace, return twice, close curly, and 4. And now here, this is where we want to find out if the projectile that we're talking about here is active. So if it is active, then we can say projectiles square brackets I dot update and projectile square brackets I dot display. So that now allows us to see them. But we're only checking the ones that are active. So if they're active, and we could say if active is true, if you prefer to see it spelled out in all of its glory and detail. So let's run this and see what happens. Okay, so first off, I'll move out of the way so it's not chasing me because it's kind of annoying. And now if I hit the letter W, S, A, and D, sweet. So I can see I'm firing my projectiles there, and they're going. So we have completed the first step of being able to fire. You can now see why I want it to fire from the middle, because if I go into my projectiles and modify it so that if we are only going based on you can see how it's off center, because the top left corner of the circle is the center of the object, so we need to offset it. So that's why we put that initial offset in, so that it is indeed firing from the middle. Now if you wanted your projectiles to come out from behind your player, I mean, that's easy enough, is you display the player after. So if you take the display for the player And we'll just copy that one and go put that down here. And notice I can easily tell where to put it because I have this closing the statement with a comment on it, and I should go and draw. So now if we run the same thing, we'll see how move the player. Okay, the player is moved, I lost the enemy, and now when I fire, it seems to be coming from player. So if you want to do it that way, go for it. Doesn't really matter. I'm going to leave it in the middle for now because I think that just works a little bit better for where we want to go. To continue with our projectiles, we need to be able to detect when our two rectangle sprites are intersecting. And I have this example here where we can see the pink object and the teal object. What we're really concerned about is how far apart their centers are. And we're trying to figure out how to do that. So there's a couple of different algorithms that we can use as means of calculating this. But the short version is we can see the pink object, it's where my cursor is, and that is at the top left corner of the object. So if we add the width to that object, so if we take that x, we add the width to it, it needs to be those two numbers added should be bigger than the x of the teal object. So if we see we have our main pink object, if we are at 135, the pink's width here is 150, I believe. Let's just see. Or it's 200, so they're all 200 by 100. So, all right, so this is 200. So if we add 200 to 153, so that's 353, we can see teal is, or 253, but teal is at 300. So when the x for the pink object gets to 200 here, and then, so we can see how the different numbers are going to work. So we have a couple of different algorithms that we can use. We can calculate our, I like this particular version here where we're using the comparing our x's and our y's to see where they're intersecting. We have a different algorithm that we can use where we're using, instead of and statements, so if, because we have to be intersecting on our 4 different values for this to make it take effect, because we have to be intersecting horizontally and vertically. So we have a couple of different algorithms that we can use on it. Essentially, we're comparing the distance between the x versus the combined half widths, and that really determines whether our objects are intersecting. But the one that I'm going to use, which is the shortest version really, is just going to be this if statement here, where it's now going to return a value. So when x is less than, so if the x is less than of object 1, so if it's less than object 2's x plus object 2's width, that means it's now going to be intersecting. So because object 2 is teal, so if we say the top left corner plus its width, that's that edge there. Now if my pink object S1's x is less than that, and the pink one's x is plus the pink one's width is greater than the x of the teal, so that would be, those two mean we're intersecting horizontally, they're coming in from the right or coming in from the left. Then we repeat the same thing with the y's. So if the y of my pink object is less than the y of the pink object plus the height of it, we intersected, and if the y of the object plus its height is now greater than the y of the TL object. So when those four things are true, our two objects are intersecting. So we're just going to work with this if statement here. Now I'm going to go back, close this out, go back into my main project here, and I'm going to just add this method. I like to just leave my key presses at the end. Once I'm done putting stuff in, I don't touch them again, where the other methods I may go into. So this is going to be Boolean rectangle intersect, and what it's going to do is take its no, not the player, this version of it is going to be my projectile, and we'll call that S1, and my enemy S2. All right. Oh, that's it. Lowercase b. I'm like, why? That didn't feel right when I typed it. Oh, and it's also, we need to return something. So now let's paste that in. Auto format. All right. So S1 is going to be the projectile. So when the x of S1 is less than the x plus width of S2, and so I think it's easier to write this out if you put it on 4 lines. You can do it all in 1 line, but it gets really long and it's harder to decipher. So we have our 2 x versions and our 2 y, not versions, conditions that we're looking for. And all 4 of those conditions must be met, and then if they are, so when all 4 of those conditions are true, then that means we're intersecting. Otherwise, it returns a false value. So, easiest way is, pause the video and write all of that out. But now, what we're going to do is integrate this into our projectiles here. So we have our projectiles that update and display, and now what I want to do is go if if my projectile and my enemy, and do remember it's really easy to go here and you forget that extra closing parenthesis. So we open a parenthesis for the if, then we have rectangle intersect, which has an open parenthesis and a closed parenthesis, so we need 2. So it's really easy to forget that second one right there. So just FYI. So what we can do now is tell this projectile when it hits. We're going to tell that projectile its active state will now be equal to false. And I am going to just flash the screen here with green, just so we can see that something happened. Like that. And I want currently I only have 1 enemy, so we're going to be modifying this. We'll have multiple enemies, and we're going to make the enemy shoot back at us. And the enemies might even be shooting better than we are, which will be kind of comical. But for now, I want the enemy just to have something happen when this occurs. So I'm going to write a new method inside my enemy class here. So let's see, we have update, we have display. I'm just going to put it up here at the top so it's easier to find. I'll just call it impact, could call it hit, something. And what I'm going to do right now is I'm just going to relocate the enemy to a new position. Now when we have multiple enemies, we probably, instead of doing this, we may dispense with the enemy. So maybe I'm trying to clear the board of enemies. So then the enemies will probably then acquire their own active state, and then we can make the enemies become inactive. So I mean, these are all, as we build, we start grabbing bits and pieces from our different classes, because a lot of the code, we realize the same algorithms, the same way of solving problems is going to come into play. So now I'm going to tell the enemy that was hit, because we only have one right now, to reset its location. So let's try this and see if we did it right. All right, so players here, and now I'll shoot out. Let's see, D, S, A, and, W, A, S, and finally D. Boom. Oh, shoot, they got me. All right, let's try again. Hey, look at that, self-defense. Now, if you feel that, hey, yeah, that shooting, that's way too fast. We don't want to do it like that. Maybe I want to slow it down and go like 200 milliseconds here. So I'm not machine gun firing, and now we can see that's a little, it's a little better. I'm hiding at the edge here. Boom. Oh, that was smart. I avoided it. Okay. Whoa. Okay. Yeah. So, steps going forward on this, we can start keeping score. We can have multiple enemies. The enemies can shoot back. We could have health bars. So as the enemies run into us, maybe, it could be we lose a life, or we could just have a health score, but we represent that with a health bar or health meter. So we're keeping track of things that way. So there's a lot of features that we could look at adding into this going forward, now that we got a core shell in place that is allowing us to shoot in all four directions. We're able to move in all four directions. We're able to measure collision detections here, which is pretty awesome. So yeah, it is shaping up. Good luck and happy coding.